All right. Hello, everyone. Welcome back. We are on lesson 6 today. Start by logging into Clever. All right. So, for your warm up, what did you learn, or what things did you learn from assignment number 11, which was the water properties lecture and notes that you should have done after lesson 5? All right, so hopefully you learned some things, and hopefully after today's lesson you feel more comfortable with them. So, like I said, welcome to lesson 6. Today we're really diving into water properties, so that we can hopefully have a really nice understanding of what's going on and how the structure of water is causing these incredible properties. So, my usual reminders, please always check assignments on Google Classroom and as Edpuzzle for comments, for returned grades, for questions, for requests, etc. If you have questions about any of those, please don't hesitate to leave a private comment on the assignment on Google Classroom, and I'll get back to you. And if I miss it and you're really like, wait, why didn't she answer? I'm human, so I miss it. So please don't feel like you're badgering me, but you can also send another message to follow up. Really try and get to the live lessons. It's beneficial for you to be there, so that I can see in live time where we're having issues, so I can kind of design our lessons based on that. Remember, we have expectations for our digital virtual classroom that are going to carry over to our real classroom. So make sure that we're continuing to practice these while we do NTI. And try again to get the live lessons. There'll be expectations in there too. Start strong, don't get behind. We're kind of at this turning point where, I don't, if you're just now getting started on things, it might be a little scary, but try to stay on top of it little bit by little bit. All assignments can be turned in whenever, but I don't recommend waiting until the end of the 6 weeks to try and do everything. All right, so this week, again, we're talking about how water structure affects its properties and then how these properties are going to affect its uses and what it does on Earth. So, thinking about water as a covalent compound with bonds that are polar as well as being a polar molecule, and then leading to some really, really cool properties. So far this week, you should have done your week 3 preview Edpuzzle as well as the water property Cornell notes. That's what our warm up was about. There was a slight change to the schedule. You have a water properties Edpuzzle now that you also are going to be doing, and then your check for understanding quiz that is over water as a polar molecule with hydrogen bonding, as well as then these properties that we're covering today. Make sure you don't do the check for understanding quiz until you've done number 12 and number 11, as well as viewed these 2 lessons, okay? Thank you guys for being here. Let's dive into our work. So first of all, I can't really have you guys draw this on an Edpuzzle, but we talked about earlier this week about how water is connected to itself through what are called hydrogen bonds. And so I kind of just want to show you where or what these will look like. So hydrogen bonds occur between the oxygen side of one water molecule, which is negatively charged, and the hydrogen side of another water molecule, which is positively charged. All right, so again, if we have this water molecule here, it is attracted, the hydrogen is attracted to the oxygen end of the other. So can you tell me what would be wrong with this? Why is that bond, this one right here? Why would that not be correct? So it's not correct because it's within a water molecule, right? That's not it. Can you tell me why this would be incorrect as a hydrogen bond? What's wrong with that one? That's wrong because opposite charges are attracted, not the same charge, okay? So these are what hydrogen bonds look like in a water molecule. All right, so, I'll have to delete these or erase them really quick. But we can see here that these water molecules are connected through hydrogen bonding. So the negative side of one water molecule is attracted to the positive side of another molecule. Those dotted lines kind of represent that for us. Again, it's not within water molecules, it is between water molecules. All right. And so the fact that water is polar and has these hydrogen bonds forming result in some really, really cool properties of water. And that's what we're diving into today. What we need to think about is we're going to think about each of these properties, and we're going to think about what property or what structural piece of water, so the fact that it's polar or the fact that it hydrogen bonds to itself, which of those two is causing this property to occur. All right. So the first property we're looking at is cohesion. So what cohesion is the property that causes water to form droplets, like you can see here, the fact that these water molecules are sticking together. So what I'm going to ask of you is, do you think that cohesion occurs because of hydrogen bonding or polarity? So occurs because of literally what cohesion means. Cohesion means that water molecules are attracted to itself. That is because of hydrogen bonding. We see here that these water molecules stick together, they stick to each other, and these hydrogen bonds are what are causing them to stick together. All right, so the next property is adhesion. This is the property that causes water to stick to other things. Like if you put your hand in a pool or in a lake, your hand gets wet. So why do we think that adhesion occurs? Do we think that it's because of hydrogen bonding, or do we think that it's because of polarity? So this one is because water is polar. Water is able to stick to other things, adhesion meaning stick to other things, other substances, as long as those other substances have some sort of charge, there's a side of the water molecule that is going to be attracted to it, which is because of its polarity. All right, next, capillary action. This is the property that allows water to reach the leaves at the very top of a tree. If we think about how plants work, water comes in through the roots at the bottom, but there's some really, really, really big trees. How does that water go up against gravity and get up to those leaves? So do we think that's because of water's hydrogen bonding or its polarity? So it's kind of a trick question. It's actually both of them. So capillary action occurs because of cohesion and adhesion. Water molecules stick to itself, creating this nice chain of water molecules that go up tubes. It also then sticks to the tube itself. And when a leaf opens up there's these holes at the top, it will pull those water chains up the tube, allowing water to reach the very top leaves of a tree. So it is both hydrogen bonding and polarity. Surface tension. So this one is the property that allows this little creature right here to sit on the top of water. And you can see as it's sitting, you can kind of see these indentations, right? It's not just floating, it is literally sitting on the surface of water. So do we think that's because of hydrogen bonding, or do we think that it's because of polarity? So the surface tension is the tightness that forms at the top of water and almost creates this film. You can even see it like in a water droplet. The fact that there is a concise like sphere that is formed. This occurs because of hydrogen bonding. Those water molecules sticking together form almost this layer or this surface on the top of water. And you guys have probably felt it if you've ever done a belly flop. The fact that when you go and you do a belly flop into water and it smacks, like it's almost hitting something solid, and we know that water isn't solid, that's because at the top layer of that water, there is this surface of hydrogen bonded water molecules that almost gives the feeling of there being something solid there. All right, what about ice floating? This is the property that allows these giant icebergs to float in water. So what is the structural piece of water that allows for that to happen? So ice floats because the solid version of water, which is ice, ends up being less dense. And the reason for that is because of hydrogen bonds. So in liquid water, the water molecules are still hydrogen bonded, but they're moving around enough that those hydrogen bonds are breaking and reforming all of the time. When ice forms, so the temperature decreases, the water molecules stop moving, and they're able to kind of form these really perfect crystalline organizations. So that's kind of why ice looks like a crystal. You can experience, and you've seen this when you put a water bottle into the freezer, right? That water bottle, it expands. That's because those water molecules are actually moving a little bit further apart than they were because of the hydrogen bonds that are forming. All right, high specific heat. This is the property that makes it take so long for water to boil when you put it on the stove. So do we think that is because of its polarity, or do we think it's because water hydrogen bonds? So This is because of hydrogen bonding. Those bonds that form between water molecules add some stability and some structure. And so for those water molecules, when you're boiling water, you have to heat them so much that the water molecules evaporate and they become gas. So they're going to leave the liquid structure. That's that steam that comes off when you are boiling water. Okay, it takes a lot of energy to get that water molecule to break free because it is hydrogen bonded to other water molecules. All right, so hydrogen bonding is here. All right, our last one, universal solvent. This is the property that allows the ocean to be super salty. The fact that the salt is dissolved into the water. Do we think that's because water is polar, or do we think that because of water hydrogen bonding with itself? So, correct answer with this one is polarity. Water is able to dissolve a lot of stuff because it is polar. Because it has a negative and a positive side, as long as something has some sort of charge on it, so an ionic molecule or other polar molecules, water is able to dissolve it. The only kind of stuff that water is not able to dissolve are non-polar substances because those don't have charges. Examples of things that don't have charges and that are non-polar are things like waxes and oils and fats, right? And so that's why if you try to mix oil and water, it doesn't dissolve because the nonpolar oil doesn't have any charge that the water molecules are able to surround and dissolve. Okay, so hopefully you're feeling better about what water properties are and why they happen. To give you just a little bit more practice, you have an ed puzzle that you're going to complete. That's assignment number 12. Assignment number 13 is a check for understanding, which you should take after you've done the notes and after you've done the ed puzzle and after you've viewed this lesson, because that will hopefully get you ready so that you can really kick that quiz's butt. So if you finished with this, how did you feel about the lesson? What did you like? What didn't you like? How did it go for you? And if you don't have any questions, you can go out and do your work. Assignments number 12 and 11. I'll see you guys next time. Thanks for your work today. See ya.